Okay, so today we're going to be starting section 3.4, which is evaluating a function. So the whole point of today is we're going to notice the math is quite simple to do. It's what are we doing to something that's written in function notation. So one of the things that we mentioned is a function is a named equation. If I have an equation, you guys all know this equation, y equals mx plus b. Very popular one, that's slope-intercept form. If I give it a name, I'm going to name that function f. Now, f is a generic name for a function. Why? Because it's the first letter of the word function. Mathematicians are very creative when naming functions. They're like, what's the first letter of the thing we're measuring? Give it that as a name. Now, the function where I read this as, where it's f parentheses x close parentheses, we read that as f of x or f at x. The name of it is f, and x is what we plug into it. The analogy we use to describe at school is, think of a car. What do you plug into a car? Gas. Gas makes car go. So if I have an x, I plug the x into the function. Function now functions. It works. So car goes. If I don't plug in an x, the car doesn't go anywhere. It just sits there. So we're like, okay, cool. I got to plug something in. X is what we consider the input of the function. After we plug an x into it, it will spit out a value. That's our answer. Typically in equations, what we've seen as our answer, as our output, is a y. Okay? Now we're just literally going to call it our f of x or f at x. So if I want to evaluate a function where I plug in a 2, I would say f of 2 produces 6, or f of 2 produces 10, or f at 2 produces 6, or f at 2 produces 10. That's all we're looking at right here. So again, let's move into, actually let's do a little bit of naming here, because this was something the students kind of got. You can see I gave them a few more examples and they picked up on it after a while. If I want to record something, oh yeah, this doesn't necessarily show any sort of cause and effect. Why do we name functions? Because it highlights a causal relationship, meaning if I want to change the output, I got to change the input. With an equation, that could be something as simple as how many cupcakes do you have sitting on your counter at home versus how many plants do you also own? There might be an effect. There might not be. Do I change the number of plants by changing the number of cupcakes? No. It could be a causal relationship. It could be something like, well, how many hours did you study versus what was the score on your test? An equation doesn't necessarily specify that. An equation just says that I can graph it. A function does say there is now a cause and an effect. So if I name an equation as a function, that means I have the ability to change the output depending on the input. So for something like, and this is how we name functions. If I want to see how far your car travels in distance based off the gas I put in it, I would say distance is a function of the gas that we put in it. So I would say d of g. Distance is a function of the number of gallons or the number of gas we put in. If I want to say your height is a function of your parents' height, how tall were they? I would say your height, I pick the first letter, is a function of your parents' height. Can't put another h there, so I'll put a p for your parents' height. If I want to say how hungry you are, and I want to figure out how many apples you ate, your hunger is a function of A, which is the number of apples. Any one of these, if I change the gallons of gas, your car goes a different distance. If I change the height of your parents, your height is going to change. We know that's not necessarily the case, but more often than not. If I eat a different number of apples, I'm going to be a different number of hungry. So that's how we read functions, and that's kind of how they're meant to be interpreted. So if I have a function like number 1, where it says f of x equals negative 4x plus 7, what that's telling me is that it's telling me that if I take f and I plug in the number 2, I will get this as an output. What am I going to get as an output? Well, I got to do this thing. That's the mechanism that the function is built off of. So this function tells me take that number, multiply it by negative 4, then add 7. If I take negative 2, or negative 4 multiplied by 2, I get negative 8. Negative 8 plus 7 is negative 1. So the function of 2 produces an output of 1. Okay? Now, I draw the arrow here. Is the arrow the way that we actually write it? No, it's not, but that does help the students understand what's happening here. I'm doing this. This is my input into this machine. This machine does some stuff, and I get an output of -1. Okay. Oftentimes what I'll do is I'll have them for the first few, I'm like, hey, it produces an output, and I'll have them literally draw an arrow for the first few of them until they get the idea that it's producing an effect. I am changing the input to get an output. Let's say you don't want -1. Let's say you wanted something different. Well, what do you have to do? I got to change the input. So here's one with a different input. I'm not plugging in a +2. What am I plugging in this time? -2. So I'm going to say, okay, f of something else, -2. I still got to do the same thing. It still works through the same mechanism. So I'm going to come over here and say, take -4, multiply by that number, and add 7. What number did we plug in? A -2. This will now give me a +8, which will give me a 15. So f of -2 produces an answer of 15. So see, we plugged in something different, we got something different out. That's how a function is read, and that's how it works. It's no different than working an equation. If you remember all your equation work from the previous math courses, easy peasy lemon squeezy. Okay, let's take a look at number 2. Number 2, I now have a different function. Maybe instead of, let's say this one was a Ford. We're driving a car, and I want to know how many gallons of gas to put in it. Well, I put in 2 gallons of gas, and I get an output of -1 miles. I didn't put enough in there, did I? Let's say over here, I plugged in -2 gallons of gas, and I got 15 miles. The analogy doesn't really hold up there, but you can see that I'm getting a different result back. Let's say I don't want to plug it into my Ford. I want to plug it into my golf cart. That's a G. So I'm like, okay, cool. A golf cart has a different mechanism to handle the gas. This is how the Ford handles the gas. This is how the golf cart handles the gas. So what do? We say G of, what are we plugging in? 10 is going to produce an output based off of this rule. I got to take half of the number, then subtract 5. So the rule says take half of what you plug in. Well, I plugged in 10. Half of 10 is 5. Subtract 5, I get 0. So the G of 10 produces an output of 0. I plugged in 10 gallons of gas, I didn't go anywhere. I don't like that. So I'll change what I plug in. Let's plug in something different. I don't want to plug in 10. Let's plug in -8. So I'll say G of -8 will produce a different output, but I got to follow the same rules because I'm plugging it into the same golf cart. This is a different day though. So 1/2 of that number, take away 5. That number this time is -8. Okay? Half of -8 is -4, minus 5 is -9. So when I plugged in -8 gallons of gas, I did get a different output, -9 miles. Okay? Now these examples weren't meant to be a Ford and a golf cart. They're just generic functions. I don't actually know what they stand for. They're just a rule that we have to follow. F says do this, G says do this. What do they both need in order to function? X. You need X values to plug them in. Now, the big thing is, do we write functions to look like this? Typically the answer is no. We write them like this. We'll give you a rule somewhere and we'll say, hey, f of -6. Now number 3, I don't see a rule for f. So most often, if you see an f of something, that either means 1, we just gave you 1, you need to go find it. Right there, I'm going to go use that one. So what I would do on this is I would say, okay, f of -6 is going to produce an answer for me, and I go follow that same rule that I did earlier. I say, okay, -4 times x, which is -6, plus 7. Actually, let me give a little bit more room because I'm going to run out of room over there. So I'm going to say, okay, f of -6 is -4 times that number plus 7. -4 times that number is going to be positive 24. So that gives me 31. Now, again, we don't write the arrow in math script, in proper math notation. I put it there just so the students kind of see, oh, change the input, changes the output. There's a cause, there's an effect. So f of -6 is going to equal 31. Now, here's the deal. Am I going to have you remember what was f for the rest of this course? No. The rest of this week? No. Maybe for the next few minutes. Certain functions have names, okay? We just named these. I don't know what these functions actually are designed for. Are they a Ford? Are they a golf cart? Are they the number of fava beans you eat? Is it the number of gophers you have to get out of your yard? I don't know. Nobody knows. Some functions are so important we'll have you remember their names forever. Like gravitational functions, they follow the same rule pretty much every single time. How you throw the object up and when it comes back down. Other things that have cause and effect have names. We remember those forever. Most of them you just come up with on the spot. So this is something we're using today. Maybe it's the number of burgers we need to flip to pay all the employees. Maybe this one is the number of guests that need to walk through the door for me to pay the bills for today. You know, maybe this is the number of presents I need to buy to make my brother happy. Maybe this is the number of presents I need to buy to make my in-laws happy. Who knows? Like, these are different rules. So typically when you see stuff like this, it's something that happened very recently. The other case that I didn't mention earlier, or maybe you have to create the rule. That happens a lot on like the end of course test. You have to come up with a function and then you'll plug in values for it. As of right now, I gave you the function, I gave you the values. You're just reading it. So g of 22 says, go find the function g. There it is. I found the g and plug in a 22. Now that's going to tell me I need to go do this thing. It says take half of that number and then subtract 5. What's that number? 22. Half of 22 is 11. 11 minus 5 is 6. So g of 22 produces a value of 6, or has an output of 6, as we say. The next thing that we did in class is I said, okay, we took a moment. I gave them like 2 minutes to work on it on their own, and everybody who got it got a little, got a reward, got a prize. We gave out popsicles. So I want you guys to go ahead and pause the video, try and knock these out, unpause it when you're done, and see how well you did. Boom, pausing should be done at this point. Let's go ahead and knock them out together. When I saw f of 1/2, I go find the function f and plug in 1/2. So f of 1/2 says -4 times that number plus 7. So -4 times that number plus 7. Shoop, shoop. I'll keep the arrows for right now because I kind of like them. -4 times that number, what was that number? 1/2. Okay. Can't really read that because my handwriting's really bad. I'll redo that. 1/2. So half of -4 is -2. So -2 plus 7 is 5. So I know when I plugged in 1/2, I got an output of 5. So f of 1/2 equals 5. How'd you do? Let's take a look at the next one. G of -2. I got G right there. Let's go ahead and do that. So G of -2, I need to plug it into this mechanism which says take half of that number and then subtract 5. The number is -2. So half of -2 is -1. -1 minus 5 is -6. Boom. So G of -2 produces an output of 6. When I input -2, I get an output of -6. So that's how we read function notation. The next part of what we're about to do is we're about to graph function notation. And you'll notice that graphing it, it's not going to be any different than graphing a regular equation, but we're going to slowly start putting more and more of the preparation on you to make sure we know how to work the actual equation when the time does come. So I'm going to go ahead and pause the video. I'm going to move the camera, and we're going to knock out the other half. Okay, so we're at our other half. Now, what we see here is we see two more functions. I have an f of x and I have an h of x. So the f of x, we know that that's going to be typically represented as a y. I'm going to say, okay, I need to graph this thing. Now notice, I gave you several x values, and just like we did before, I have to evaluate that function. Now, unlike what we did before where we showed each step, when we're graphing something, we don't always need to show every step. We can say, hey, I evaluate each one of these out. If you're having trouble though, you're going to have to. So one of the things that I told them, as I said, try it out. Let's see how we do. So remember, x, I plug it in. This is my output, my input, my output. So if I plug in a -2, see if you can follow this. I have to double it, then add 5. So if I plug in a negative 2, 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. If you followed that, that's all you need to put. If you didn't follow that, you need to show your work. So what did we do right here? How did we get that 1? Well, I used that as my input. So I said, okay, f of negative 2 produces 2 times negative 2 plus 5. 2 times negative 2 is negative 4, plus 5 is 1. That's where we got the 1. We plugged it into the function and we got that as an output. And that's all we really care about after we plug it in is, what do I get? I studied for this long, what's my test score? You know, we don't really care how we did the test necessarily. Most people there are like, I'm concerned with how much did I study? Was it worth it at the end? So let's say the negative 1. Let's see if we can follow it this time. Plug in the negative 1. So 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. Still confused? We got to show our work. So f of negative 1 equals 2 times negative 1 plus 5. I'm going to draw the little arrow there. It produces that. I evaluated out. That's where that number comes from, is I plugged in the negative 1. 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. That's where the 3 came from. Okay. Let's try it one more time. 2 times 0 is 0, plus 5 is 5. If you're confused as to where that came from, show your work. So f of 0 produces a 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. That's where that 5 came from. But again, only show this part if you're struggling to find where did these numbers come from, what are we doing right here? Okay? If not, if you've got this process down, mostly these aren't going to be too terribly complex. They're 1, maybe 2 steps. Most of the functions that you have to evaluate, if you have to do those on quizzes or tests or on like the EOC, they're going to be several steps long. Best advice, show your work. On graphing like this, if it's a 2-step like this, you don't really need to. When I plug in the 1, 2 times 1 is 2, plus 5 is 7. If I plug in the 2, 2 times 2 is 4, plus 5 is 9. That's really all you need to show if you've got this process down. If not, show plugging in the 1, show plugging in the 2 to figure out where those 7s and those 9s came from. Then at this point, it just becomes rinse and repeat of what we did the other day. I need to be able to go left 2 and right 2, so I'm going to make sure I have enough space for left 3 and right 3. Okay, so I've got something like that. Up, down, label my y. I need to be able to go, I don't need to go down, but I need to go up 9, so I give myself 10 spaces to work with. Okay, so at minimum, your graph should look something like this. That's my x. Now again, you can draw your graph much bigger if you want. It's perfectly okay. And then as I'm graphing this was another one of the things that I had to remind students. The x value tells us if we go left or right. The y value, or the f of x, tells us whether or not we go up or down. A negative x means left. A positive x means right. A negative y means down. A positive y means up. So negative 2, positive 1 means left 2, up 1. So I start at the origin, left 2, up 1. My next coordinate tells me left 1, up 3, and I go back to the origin. Left 1, up 3. This one tells me don't go left or right, but go up 5. So I start back at the origin, up 5. Right 1, up 7. So I go back to the origin, right 1, up 7. This one tells me right 2, up 9. So again, I start back at the origin, but I've got all these points right here. Now, the other thing I told him is I don't trust myself to draw a straight line, so I use a ruler. This is my straight edge. That way I can get a straight line. Some of them I know are really, really good at drawing straight lines. A lot of them are not. So if you're one of those that's not, get yourself a ruler, get yourself something that you can draw a straight line with. Okay? I don't trust myself to draw a straight line on a whiteboard. They tend to bend at the ends. So because I don't trust myself, I just say, hey, there we go. Straight line every single time. Okay. After I make sure that my axes are labeled, x and y, I have my arrows on them. My arrows are on the end of my graph. I'm going to go ahead and I'm going to circle the intercepts right here. This is 0, 5. I knew that was going to be the case because I saw a 0 in my table. That really helps us out with some of the names if you see a 0 in the table. The other one, not in my table. It looks like I'm heading towards 0, so it's probably going to be somewhere over here. But this one is going to be at, looks like negative 2.5, 0 for that one. Awesome. So see, the second part, just like what we did the other day, the first part is making sure we understand how to evaluate a function. Now for this one, I've got more of these ordered. They're not in yet, so I'm going to have to add some lines to my graph. Again, this shows that I don't trust myself to draw a straight line. You're like, Mr. Johnson, why are you drawing on your graph already? I know it's not going to fit, but we don't know that just yet. Okay, so this is h of x. This is something different. Now, some of the classes didn't get to this one because we were moving a little slow, or maybe the transition time between wasn't quite the best. But pretty much every one of them did get to hear the, why did we pick -6 and -3 versus the -2, -1, and 0 like the previous one? Why did I pick different inputs? Because as of right now, your eventual job is to pick your own inputs. I've taken away the outputs. You have to figure that out. But I'm still picking the inputs. Why did I pick those numbers specifically? Give you a moment to think about that. Look at what I'm multiplying x by. Can I multiply 2 by any one of these and get nice whole numbers? Yes. I'm multiplying my input by 1/3. That means I'm multiplying it by 1 and dividing by 3. So I want numbers that very easily divide by 3 after being multiplied by 1. Okay. So 6 divides by 3, 3 divides by 3, 3 divides by 3, 6 divides by 3, and 0 divides by 3 all very easily. Could I have picked numbers like -2 and -1? Yeah. I would have ended up with fractions as my answers, which means then I would have to round that to decimals, and that would just mean that the graph might be a little hard for some. Again, this is kind of an introductory portion, so I'm not really too terribly concerned about giving fractions and decimals just yet. We will eventually get to them though. So I picked numbers that I know will divide by 3 because I looked at that coefficient. That's where those numbers came from. So let's go ahead. And again, if I plug in a value of -6, 1/3 of 6 is 2. Negative negative makes that a +2. +2 plus 7 is 9. If you don't understand where that came from, all you got to do is say, okay, h of -6 produces a value of -1/3 of -6 plus 7. 6 divided by 3 is 2. Negative negative makes that a +2. 2 plus 7 is 9. That's where that came from. If you need to show more steps on the fractions to make sure you get the answer right, by all means, go for it. Again, this is just to make sure we're following through. If I plug in a -3, 1/3 of 3 is 1. Negative negative makes that a +1. Plus 7 is 8. If you don't follow that, h of -3 produces a -1/3 of -3. 1/3 of 3 is 1. Negative negative is a +1. +1 plus 7 is 8. That's where that came from. Plug in a 0. -1/3 of 0 is 0. Plus 7 is 7. 1/3 of +3 is -1. -1 plus 7 is 6. 1/3 of 6 is 2. Make that a -2 plus 7 is 5. Okay. So given those, I need to be able to go left 6, right 6. So what I'm going to do is I'm going to give myself 6 spaces on the left and on the right. Okay, I've got my line right there. 6 spaces on both sides. I also know that I need to be able to go up 9. So I'm giving myself 10 spaces on top. Bingo. So I have my x-axis, and I have my y-axis. I'm going to graph my line. Remember, that tells me left or right. So left 6, up 9. 1, 2, 3, 4, 5. And my new line, up 9 points, is going to be right there. I knew we were going to go over. That's why I drew it. Left 3, up 8. So go back to the origin. 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. Stay in the middle, go up 7. Go to the right 3, up 6. Go to the right 6, up 5. I don't trust myself to draw a straight line, so I'm going to go ahead and I'm going to draw a straight line right here. Arrow on each end, and label my intercepts. Now I know it's eventually going to intercept the x-axis somewhere over here. I'm not too concerned because that's really, really far away. This is going to be 0, 7. I knew so because that was going to be on the table there the entire time. Now, eventually we'll get to the point where I do need to figure out when is that going to intercept, but that's for a later lesson. At this point, we should feel pretty good about what's going on. Let me go ahead and write the homework on the board. Guess I'll do it right here. So the homework, this is section 3.4 for 3.4, is going to start on page 129. Okay, it's going to be on page 129. We're doing 2 different pieces. It's going to be number 1 through 8 odd, so that's 4 questions, and then numbers 21 through 24 all. Okay, so I've got 2 different sections. Numbers 1 through 8 odd are just like what we did over here, where we evaluated functions. And then those 4 questions at the bottom are graphing. So one of the things I don't think I mentioned on the video, but I did mention in class, if it is a graphing style question like those 4, it must be on graph paper. We're trying to get to the point where we get good with graphing, and we're going to need to find these intercepts. So we want to practice on the thing that we're eventually going to use. So please make sure that any graphing questions are on graphing paper. You can put the whole thing on graphing paper if you want. Specifically, those 4 questions have to be on graphing paper. That's going to be due tomorrow. This is going to be due Tuesday, 10/7. Okay, hopefully that answers everything. Tomorrow is going to be a review day. They're going to have a full day to work on their Delta Math for the chapter review guide. I'm going to go over homework questions with them in class, anything from the chapter that they didn't quite understand. If they're missing anything, like they have questions about it, make sure they have their notes. I'll answer anything like, hey, this is how we did that thing. Just a general catch-up day. We're not going to be turning in work late or anything like that, but it is a general catch-up day to make sure we understand what's going on, because that test is going to be the big grade and the last one before the 9 weeks ends. So have an excellent day, and I'll see you tomorrow.